Hello friends, we are here again with one more interesting topic. Today in this video, we are going to learn about airfoil terminology, angle of attack, impact of angle of attack on lift and stall. Let's start the video. In previous video, we have already learned what is airfoil. To remind you, I'll give one simple explanation for airfoil. So it is just a cross section of an aircraft wing. I think this would be a good example for aircraft airfoil section, where we usually found the greater curvature on the top than the bottom surface. So here you can see the flow which is moving over the top surface is known as upwash, and the flow which is moving at the bottom surface, you can observe here, we call it as a downwash. We have also seen that due to the pressure difference, it's gonna create lift. Now come to the airfoil terminology. Here you can see the various parts of the airfoil which are illustrated here. So we will discuss each one of them. The first one is upper surface. Here you can see the upper surface of the airfoil, which is also known as the suction surface due to the low static pressure. And the next one is lower surface, which is the bottom surface of the airfoil. So it is also called as pressure surface due to the higher static pressure, that is lift. So this point is leading edge, which is the nearest point to the airflow from the airfoil, and the aft end point, that is trailing edge, which is the farthest point to the airflow from the airfoil. So the next is mean camber line. It is just a line which divides the airfoil into two equal half sections. So it also connects the leading edge and trailing edge. Chord line is just a straight line which also connects the leading edge and trailing edge. Max camber is the maximum thickness between the mean camber line and the chord line, and it should be measured always perpendicular to the chord line. So the next one is maximum thickness. So by name itself, it defines that it is a maximum thickness of the airfoil. So the last one is chord. So it is the distance between the leading edge and the trailing edge of the airfoil. So the next is angle of attack. Angle of attack is just the angle between the chord line and the relative airflow, which is indicated by the alpha. You can observe on the picture. So the next is the impact of angle of attack on lift. So if you change the angle of attack of airfoil, the lift is keep on increasing. You can observe on the graph that the lift is keep on increasing with angle of attack until the stall point is reached. So now we will discuss what is stall. When the angle of attack of the airfoil is increased gradually, the lift force increases rapidly up to a certain point. You can observe here, and then suddenly it begins to drop off. When the angle of attack is increased to a point like where we are obtaining a maximum lift, that point is known as a stall point. We also call it as a critical angle or a stall angle. You can observe here, due to the high angle of attack, the flow on the upper surface loses its kinetic energy, so which later tends to create a turbulent flow. So that is not a suitable condition for aircraft. You can observe here in the animation like how the flow is converting from laminar to turbulent due to the high angle of attack. So this would be the effect of airflow over an airfoil when the stall angle is reached. Hope you guys have understood the topic. We will meet again in another video with one more interesting topic. Stay tuned for my upcoming videos. Please like, share and subscribe. Thank you guys for watching.